Honeycomb. The hexagonal shape of the honeybee cells has attracted the attention of humans for centuries. Why do bees build this kind of cells? How can they achieve such a spectacular structure? Early natural philosophers like Marcus Trench's Varro, based on the observation that hexagons possess the highest surface per perimeter ratio, compared to other polygons that can be used for tiling the plane, suggested that honeybees build their hexagonal cells in order to achieve the best economy of material. 18 centuries later, Darwin surpassed the early teleological explanations, noting that the swarm wasting least honey in the secretion of wax would have succeeded best. Precise data about food conversion rates in the production of beeswax support the intuition of the great naturalist. However, for a complete understanding of a given phenomena, both the proximate and ultimate sets of causes have to be explained and also interpreted. In other words, both the why and the how questions need to be addressed here. Varro suggested the correspondence between bees' legs number and the angles of the comb cell might hint of a possible construction method. In any case, the geometer's skills of bees were not questioned for a long time. However, cells are not hexagonal when they are built but rather circular, as already suspected by ancient observers, and easily demonstrated by studying wax combs in the early stages of construction. Rasmus Barcelon suggested that hexagons would result automatically from the pressure of each bee, trying to enlarge as much as possible each cell, while Thomson argued that it is surface tension that molds the soft wax into a hexagonal pattern of cells, as a result of the formation of three 120 degrees angles between the wax walls converging in a triple junction. Burke and collaborators provided support to this latter hypothesis by studying the wax condensing around an array of rubber banks, while Carello and co-workers reached a similar conclusion by modeling the effect of surface tension at the triple junction between adjacent cells. This latter evidence supporting the interpretation of the honeycomb architecture as the result of blind physical forces rather than biological engineering lead Bolt to state that there doesn't seem to be much room left for the honeybee's engineering prowess. However, a recent study questioned the possibility that surface tension alone can explain the process. In particular, Bauer and Benefield argued that bees do not heat up wax to the temperatures needed for the wax to reach the liquid equilibrium, and proposed an alternative explanation based on the mechanical shaping of cells. In any case, available data about the thermal properties of beeswax indicate that the onset of the wax melting temperature is very close to the range observed by Bauer and Benefield. In conclusion, the formation of the hexagons is still a matter of debate, and a definitive conclusion has not been yet reached. Now, let's investigate how different cell shapes might affect the amount of wax and the space used to build a honeycomb. We will conduct two investigations into how different types of shapes might affect this amount of wax and the space needed to build these cells. Investigations should be conducted in sequential order, because each one builds upon previous investigations. The first investigation is honeycomb cell shape, while the second one is sharing cell walls investigation. Concerning the honeycomb cell shape investigation, let's imagine for a minute that we are workers' bees. What would the honeycomb look like if the cells were different shapes? Using pennies and pattern blocks, or shapes cut from? We will experiment with different geometric shapes to see how they would work as honeycomb cells. We try to arrange as many shapes together as possible, with the least amount of wasted space. Remember that honeycomb cells are never a mixture of multiple shapes, so we can only use one shape at a time. For the second investigation, sharing cell walls investigation, we may have noticed that from the previous investigation that arranging cells resulted in a big gaps between each shape. If honeycomb consists of circles, there would be a lot of waste space between cells, and a worker bee would probably have to expend a lot of energy filling in those gaps with wax.